Hello everyone, in this video, I will be discussing to you the reference angles. Reference angle is the acute angle formed by the terminal side of the angle and the x-axis. By illustration, we will try to use the rectangular coordinate system. X-axis is the horizontal axis and the y-axis is the vertical axis. Let's just see this is our terminal side of the angle. Now, since we are to form the angle from the x-axis or with the x-axis, then there will be two choices. It's either using the right side of the x-axis or using the left side of the x-axis. If we will use the right side, this is the angle this time. Or if we use the left side, then this is the angle, the red one. If we are to choose between these two angles, the reference angle is actually the yellow one. It's because the reference angle is always an acute angle. Notice that the red angle is an obtuse, so it's never the reference angle. To clarify, we have the second situation. Okay, so let's just say this is the the terminal side. So we can get this angle or this angle, the yellow or the red one. In this case, the red one is our reference angle. It's because it is the acute angle. The third situation, we have this terminal side in the third quadrant, and this time we have to consider these two angles from the x-axis. Okay, the red one is our reference angle because again we are to consider the acute angle. Lastly, for this one, we have this terminal side in the fourth quadrant, and we have these two choices. The yellow one is our reference angle since it is the acute angle. So there's only one thing that you should remember when we talk about reference angle. It's always the acute angle. Okay? It's always the acute angle from the x-axis. Now, talking about how do we get the reference angles? Let's just assume that theta is the positive angle in standard position. Okay? So when we say angle in standard position, it starts from the right side of the x-axis. And since we consider the positive angle, then that means the rotation is counterclockwise. So if we will consider the first situation, or when the terminal side is in quadrant 1, okay, the reference angle is just actually equal to the angle in standard position. Because notice that if we will consider this angle, the yellow one, okay, this is also the angle in standard position. That means we started from the right side of the x-axis and we rotated counterclockwise going to the terminal side. So basically, the reference angle is just equivalent to the angle in standard position if the terminal side is in quadrant 1. Now, what if the terminal side is in quadrant 2? Okay? So that's actually equal to 180 degrees minus the angle in standard position, or that is actually the straight angle minus the angle in standard position. Now, why is that so? Notice that the yellow angle is actually our angle in standard position. Okay? And our goal is to get this red angle. How do we do that? If you will try to observe, the yellow angle plus the red angle is actually a straight angle or equivalent to 180 degrees. Now, if we want the red angle only, then we have to remove the yellow angle. And that yellow angle that we are going to remove is actually the angle theta in standard position. That's why we consider the formula for the reference angle when the terminal side is in quadrant 2 as 180 degrees or the straight angle minus this yellow angle or the angle in standard position. Okay, so it applies to all angles when the terminal side is in quadrant 2. If it's in quadrant 3, okay, if it's in quadrant 3, then R is actually equal to the angle in standard position minus 180 degrees. By illustration, let me explain it. Okay, just consider this green angle. Okay, so this green angle is actually from the right side of the x-axis going to the terminal side rotating counterclockwise. So that's the green angle. Okay. Now we only need this red angle. So we have to remove this portion. Okay, so this portion just until here, until the right side of the the left side of the x-axis. And that is actually 180 degrees. Okay, so I'll just the green angle, the whole green angle is actually the angle in standard position, or the theta. Now, if we want this red angle only, we have to remove this part. Okay, and that part that we remove is actually 180 degrees. So that's why we have the whole green angle minus that part, which is 180 degrees. So we have theta minus 180 degrees. Then lastly, we have quadrant 4. This time we have 360 degrees minus the angle theta in standard position. By illustration, we can actually explain this one. I can actually explain this one. Okay, so this green angle is a full revolution, or equivalent to 360 degrees. Now remember, we only need the reference angle, this yellow one. Okay, so how do we do that? It's actually by removing that portion. Okay, now if you will try to observe what is that portion equivalent to, well, that portion is actually equal to the angle theta in standard position. So actually this part from the right side of the x-axis, counterclockwise rotation going to the terminal side. So we are trying to remove the angle in standard position. So from the whole 360, the green angle, we will be removing the angle in standard position. So the reference angle is basically equal to the full revolution minus the angle theta in standard position. So let's have some examples. Okay, so all you have to do is to recall all those four formulas or four patterns. So if it's in quadrant 1, R is just equal to theta, or angle in standard position. If it's in quadrant 2, that's 180 minus theta. If it's in quadrant 3, the reference angle is theta minus 180 degrees. Or if it's in quadrant 4, then the reference angle is equal to 360 degrees minus theta. So our goal is to find the reference angle given the angle in standard position theta. Okay, so here are the items. Number 1, theta is 63 degrees, 253 degrees for number 2, 135 degrees for number 3, 317 degrees for number 4, and negative 193 degrees for number 5. Now for number 1, since this is in quadrant 1, okay, 63 degrees is in quadrant 1, so we will consider this pattern or formula. That means R is just equal to theta. Or the reference angle then is just equivalent or equal to 63 degrees, and that's it. So as simple as that. Now for number 2, we have 253 degrees. This is actually in quadrant 3. So I am considering the formula in quadrant 3. It's theta minus 180 degrees. Now, 253 degrees minus 180 degrees. So I only substituted the value of theta from number 2. So 253 minus 180 degrees, that's equivalent or equal to 73 degrees. So the reference angle of 253 degrees is 73 degrees. Now for number 3, we have this R equals 180 degrees minus theta, since number 3 is the terminal side in number 3 is in quadrant 2. 135 degrees is an angle with a terminal side in quadrant 2. So we have to consider the formula in quadrant 2 to get the reference angle. So substitute 135, so that should be equal to 180 degrees minus 135, or that's 45 degrees for the reference angle. Okay. Then we have number 4. So for number 4, we have 360 degrees minus theta. It's because notice that number 4 has a given angle, 317 degrees, whose terminal side is actually in quadrant 4. Okay? So since it is in quadrant 4, we have to follow this formula in quadrant 4. 360 degrees minus theta. Substituting the value of theta will give you 360 degrees minus 317 degrees. Or in short, you have 43 degrees. So the advantage of remembering all these formulas from quadrant 1 to quadrant 4 is you don't need to illustrate. But just in case you forget, then I advise you to illustrate the angle and then try to analyze how to get the reference angle. Okay, so it's like you will analyze now instead of memorizing, and I think it's better if you will try to do it, since it will be a lifelong learning. Now let's proceed to number 5. So for number 5, we have this theta equals 193 degrees. To solve this one, let's just try to assume that the negative 193 degrees is positive 193 degrees. Actually, it will not matter if we are only to get the reference angle. So all you have to do, okay, to make it easier, is just make the negative angle into a positive angle, because it will only lead you to the same reference angle if you do that. Now, if we take positive 193 degrees, then it will give you an angle whose terminal side is in quadrant 3. Or that means we are to use r equals theta minus 180 degrees. So the reference angle therefore is equal to 193 degrees minus 180 degrees, or that should be 13 degrees. So again, if the given angle in standard position is a negative angle because the rotation is a clockwise rotation, then all you have to do, if you are only to get the reference angle, is just take its absolute value and solve the reference angle according to the formulas that we have. Now, in some other case, it will not be like this. In some other cases, you will be given an illustration and then you will analyze, get the reference angle then. Example, if we have this rectangular coordinate system and the reference angle is in quadrant 3, just take this red angle. This angle is not an angle in standard position, just like what we have in the previous examples. Now, let's say it is given as 147 degrees and your goal is to find the reference angle. So the green angle is actually the reference angle. Okay, so you will use your analysis this time instead of relying on the formula. So the advantage basically in analyzing is you will not rely on any formula. By then, you will try to remove that portion of the red angle in order to get the reference angle. Okay, so what is that angle equivalent to? What are we trying to remove? That's actually equivalent to 90 degrees. Okay, so notice that this portion of the angle here is a 90-degree angle. So we are trying to remove a 90-degree angle, or that should be 147 degrees minus 90 degrees. So this time you have the reference angle equal to 57 degrees. Again, in this portion, you will not be relying on any formula. Instead, you will use your analysis and logical thinking. Next one. Given this terminal side of the angle, and you have this yellow angle equivalent to 28 degrees. Now your goal is to find the reference angle, so you have to find the green angle this time. So how do we do that? Of course, as you can see, okay, all you have to do is to remove the yellow angle. So what should we do? In this case, guys, notice that the yellow angle plus the green angle is a right angle. Okay? Let me repeat. The yellow angle and the green angle when combined is equal to 90 degrees. So if I only need the green angle, I need to remove the yellow angle which is equal to 28 degrees. Or that should be 90 degrees minus 28 degrees. Now the reference angle is just equal to 62 degrees. So that's it for reference angle, people. Thank you for watching. Bye.